Hello friends, today I am going to talk about friction. So welcome to my channel Sony Singh Physics. Friction is a force which comes in existence when two surfaces come in contact to each other. These surfaces can be solid, liquid or gases. Friction force is proportional to normal contact force. Since it is a force, its SI unit is Newton. The formula to calculate friction is F is equal to mu R, where mu is the coefficient of friction and R is the normal contact force. Friends, if you like this video, hit the like button and subscribe to my channel. Coefficient of friction depends upon the surfaces which come in contact with each other. The value lies between 0 and 1. 0 means there is no friction at all and it is only possible with superfluidity. The value 1 means friction force and normal contact force are equal to each other. The value greater than 1 is also possible in some of the cases like a silicon rubber. Friction force is of two types, static friction and kinetic friction. Static friction means surfaces are in contact with each other and they are at rest. Kinetic friction means surfaces are in contact with each other but there is a relative movement among each other. Friends, we say that static friction is greater than kinetic friction. You know why? Yes? Okay, I'll tell you. When surfaces are in contact with each other and when they are at rest, they develop a high intermolecular force, adhesive force among each other. Once they start moving, that strong bond has been broken and the resistive force reduced. Friction force and normal contact force are perpendicular to each other. Friends, do you know which is easier, pushing or pulling? Yes, it is pulling. You know why? I'll tell you. Let us come to the board. This is pulling and this is pushing. In both the cases, same object and same surface is there. So because of that, the coefficient of friction mu will be same. The same force P is working in both the cases. Now we'll see first in case of pulling what happened. The component of this force P, that is P sin theta vertically above and P cos theta horizontally. The other two forces are working on this object, that is mg weight and R is the normal contact force. So the value of R in this case is mg minus P sin theta, whereas value of R in the case of pushing is mg plus P sin theta. Now when we see the friction force, in case of pulling it is mu into mg minus P sin theta, whereas in case of pushing it is mu into mg plus P sin theta. So the friction force is getting increased in case of pushing and it is getting decreased in case of pulling. That's why we say that pushing is difficult than pulling or pulling is easier than pushing. This is one of the questions from a past year paper. The question is 6 kg mass of an object is at rest in limiting equilibrium. Calculate the coefficient of friction between the block and the plane. This was the diagram which was given in the question. The inclined plane is at 20 degree and 10 Newton force was applied on that object. Now we'll see that how to factorize this 10 Newton into components. Since it is a pushing force, we'll extend it till here and then the horizontal component 10 cos 20 will be in this direction and vertical component 10 sin 20 will be vertically downward. These are the component of weight mg and this is the normal contact force R. So the R will be equal to mg cos theta plus 10 sin 20. Here theta is 20 degrees, so 60 cos 20 plus 10 sin 20 will be equal to R. Now we'll see what will be the value of F. Next will be forces along the plane. Since the object is at rest, so 10 cos 20 minus 60 sin 20 plus f, which is working in this direction, will be equal to 0, and when we simplify it, f will be equal to 60 sin 20 minus 10 cos 20. Now we have to calculate a coefficient of friction, that is mu, that will be equal to F by R. Since the object is in limiting equilibrium, mu will be equal to F by R. So now we'll put the value of F and R in this equation. We'll get the value 0.186. That is our answer. Friends, you may have gained the impression that friction always acts so as to prevent motion, but this is not correct in all the types of movement. In case of running, cycling, driving a car, and the same type of movements, friction actually supports. First, we'll see in case of running. When an athlete runs, the shoes of the athlete pushes the ground backward, and because of that the ground applies friction force in the forward direction. So in this case, friction is supportive to the running of the athletes. In the same case, in cycling, the wheels of the cycle push the ground backward, and because of that ground applied friction force in the forward direction. The same thing happens in driving a car. So in such kind of movement, friction is actually supportive to the movement. In some cases, friction is non-supportive. Actually, we don't need much friction over there. That is machines. In machines, we need the surface which has to be smooth. So to make the surface smooth, we use oiling, greasing and all those things to reduce the friction. Friends, I hope you have got some idea about friction. If you have any doubt about the content or any query, please do comment, share and subscribe to my channel. Thank you.